Hello, everyone. My name is Venman. Welcome to my talk on a field guide for safe Istio upgrades. And today in this talk, we're going to talk about the various Istio upgrade strategies, some of the advantages and disadvantages of them, and how you can pick which one makes sense for you, depending on what your needs are and what your organization's needs are. Some of the gotchas that you need to be looking out for, how you can be prepared for the upgrade, and what to do after the upgrade, as well as just general best practices to kind of set you up for success moving forward. So like I said, my name is Venman. I've been working with Istio or on Istio since pretty much 1.0. For last 4 years or so. I can't believe Istio is almost like 5 now. I joined Solo about a year ago, but before I joined Solo, I was at IBM where I was also working on Istio. I spent a couple of years serving on the Istio steering committee, and I've been part of creating a lot of Istio blogs, videos, workshops, demos, etc. At Solo, I lead the US East field engineering team. So it's about 9 of us. And what we do is, simply put, we just help customers with Istio. Solo offers enterprise Istio, and we kind of see customers coming in using Istio at various parts of their Istio adoption journey, all the way from a single cluster with a couple of namespaces, all the way to multiple clusters spanning regions, public, private, etc. So kind of depending on, when they come in and when they get involved, some of the users that we see are still on Istio 1.7, and they're kind of slow to move on to newer versions because it's kind of intimidating, and they're worried what if something goes wrong. So this conversation about Istio upgrades is very relevant, and it comes up quite often. Okay, so this is a simplified view of the Istio architecture, right? So, everyone has seen this, there's a control plane on the bottom, the data plane on the top. There's a single, it's a very simplified view. But if you think about it, Istio, from an architecture perspective, has come a long way in simplification, right? Not long ago, the Istio control plane used to be made up of multiple microservices: Mixer, Galley, Pilot, Citadel, etc. So now we've kind of combined it all into a single microservice, Istio-D. But we know that the whole thing is just not a single piece. There's still multiple pieces that make up Istio, right? There's the sidecars next to your applications, there's gateways, and then there's a control plane, and then there's some stuff that's running in the background that's doing kind of all kinds of magic. So the first thing you should do is try to understand the pieces that Istio is installing. And this will help you understand exactly what's going on in the upgrade and make it kind of less intimidating, right? So if you do Istio cuddle manifest generate, and you point it at your Istio operator file or one of the pre-configured profiles, default, demo, minimal, etc., you'll get an output of just all the YAMLs of everything that will get installed into your cluster. So if you were to run that on the default profile using that command I'm showing you, these are all the YAMLs that get, would get applied to your cluster. There's custom resource definitions. These are your definitions for your gateways, virtual services, destination roles, service entry, etc. Those are the CRDs. There's 2 deployments, the Istio-D and the gateways. They're matching services, so the Istio-D service as well as the ingress gateway service. The validating webhook configuration, which is responsible for when you apply new Istio config, the piece that's making sure that config is valid. Next, the mutating webhook configuration. This is whenever a new pod starts up, you want it to automatically inject that sidecar. So that's what that webhook is doing. There's a couple of config maps. One for the Istio configuration, the Istio control plane configuration. And then the second config map defines what your sidecar should look like. You'll see a few Envoy filters. Those are mostly related to stats. And then the horizontal pod autoscaler and pod disruption budget to just kind of make sure that your Istio D and your gateway services are, always running the way you want them to in an HA fashion. Okay, so now we just talked about all the components. Next, let's talk about how are they wired together. Okay, so first, let's start from the control plane and then work our way up to the data plane. The most basic component of the service mesh is like the main control plane, which is the Istio D deployment, which then creates a pod. So that's Istio D pod running on the bottom right. So next, there's the service, right? So these are this is the way for your sidecars and your webhooks, et cetera, to talk to your control plane. So this service exposes various ports, things like, 15010 and 15012 for your XDS traffic. And then there's 15012, there's 443 for your webhook injection. So it exposes some ports so that other things can talk to it. Other things such as the mutating webhook configuration. So whenever a new pod is getting created in your cluster, you want this webhook to grab it and then send it to the control plane to inject that sidecar config, right? So that's what this webhook configuration, and you can see how that service knows about the control plane location. There's a service name, the path, the port, et cetera, directly in the webhook configuration. And then once the mutating webhook injects the sidecar, how does the sidecar know the address of the control plane? And that is a couple of variables here. You can see the CA address is, that's more for certificates. So that's how it gets, it's certs. And then proxy config is the XDS address. So this is where the sidecar knows to talk to the control plane to get its config from the clusters, listeners, routes, et cetera. So if you were to look in your own pod YAML, you might not see this proxy config discovery address. And that's because there's a default discovery address. And it's only when you overwrite it, or if you're using something like revisions, would this value get injected. But I'm showing it here for learning purposes. Next, let's talk about security. We've covered the components, we've covered how they know about each other. Next would be certificates so that they can talk to each other securely. By default, when you install Istio, it generates self-sign like root certificates, and then that's what gets used to sign its workload certs. The best practice for running in production is that you don't use that self-sign feature and instead use some external service to create and store your root CA. And from that root CA, you generate an intermediate CA, which you provide to your workload cluster. So in this case, that's that secret, that CA cert secret, is that it has information about that intermediate CA that you want Istio to use. Things like the validating webhook configuration and the mutating webhook configuration, they need to talk to the control plane. So they need the root CA information. And that info is directly in the config for the mutating webhook configuration and the validating webhook configuration. And you can see that in the CA bundle line of the config. So now, why is that important? Sometimes you do an update and you're not able to apply any more config. Well, that's probably your validating webhook configuration is not able to talk to Istio-D. Or you're not able to deploy a new pod. Well, that's probably your mutating webhook configuration is not able to talk to Istio-D. And if you check the Istio-D logs, you'll see something like some cert-related failure, right? And if that happens, you can quickly kind of compare these two values. And if it's out of sync, you can restart Istio-D, which is then supposed to go modify mutating webhook and validating webhook configurations. So they need to be in sync for that communication to happen. And then switching over to your data plane, your sidecar proxies, how do they have the root CA information so that they can validate traffic against like the workload's root of trust, right? And that is in a config map. In every Istio injected a namespace So if you label your namespace with injection enabled, IstioD will create a config map, and this config map will have the root cert information. So after an update, if something's not going well and the logs show anything related to certs, this is a good thing to check it first. You want to check to see if your namespace has this config map. What is the root cert value? Check your webhook configuration, check your mutating webhook configuration, and then check that all of that matches what's in your CA certs. Okay, so switching to another best practice as far as upgrades goes, separate your components, right? The main components, the IstioD, which is the control plane, your gateways, and any other config that you have, additional gateways. So in this example, I'm showing on the left is the IstioD Istio operator. The one in the middle is your ingress gateway for north-south traffic, and you might have a second gateway for east-west, multi-cluster traffic. Or many users deploy multiple ingress gateways, one for each different line of business. So first thing you want to do is separate all three Istio configurations so that you can not only update them individually, but just manage the entire life cycle of them independently. If you wanted to update your port for your ingress gateway, your external ports, for example, you don't want to potentially take down your entire system with a bad update if you just want to update just that one ingress gateway. So having multiple Istio operator files lets you delineate those different configurations. It also gives the ability to kind of hand off the control to your different various teams. Maybe your gateway, you have a gateway team that's responsible for managing your gateway configuration. So let them manage their Istio operator file, and then your platform team can manage the control plane, et cetera. Another thing that you should definitely do before you do an upgrade is capture the current state of things. Like, clean up around the house a little bit, making sure that your cluster, your Istio is running properly. There's no pending errors. There's no like reconcile loops that are happening, etc. So do all the sanity cleanups, right? The IstioCTL analyze tool is very good at figuring out if you have some bad config, if you're not defining your ports properly, if you're using any type of deprecated APIs. The analyze command should be your number one go-to whenever things are not working well, just to make sure that all of your config is valid. Next, if you want to dive in a little bit deeper, the IstioCTL proxy status will show all of the services, all of your workloads that are part of the mesh. So it's a good way to validate that, yes, these workloads are supposed to be part of the mesh, and they are part of the mesh, and as well as it shows you whether they are up to date in terms of Istio. Like, do they have the latest route configuration, listener configuration, cluster configuration? You should see sync or not sent in all of those kind of columns that when you run the proxy status command. And if it's not, then you know that one of your pods has a problem. You should fix that before you start your upgrade procedure. And then once that looks good, if you're ready to kind of do an update, you should run the IstioCTL X precheck command. So get the Istio cuddle from the next version, the version that you're going to, and then run the precheck. And that verifies that you have the right cluster, Kubernetes cluster permissions, any incompatibilities you might have. It also checks to see if there's any known problems. So the precheck has a bunch of validators in it. So it can do things like, for example, in Istio 110, workloads were no longer allowed to bind to the local host port. and then expose a port, because that would be incompatible with 110 forward out of the box. So the IstioCuddle pre-check command can check for that, can check to see if there's any of your workloads were binding to like localhost instead of like 12.0.0.1. And then, make sure that there's no incompatibilities and fix any issues. So once you're at that point, you fixed all your Istio configurations, everything's working good. Back up all of your Istio CRs. So you can do kubectl get istio-io. That's a very convenient way to grab all of the Istio CRs and then run this command and output it to a file. Now you might be thinking like, I already have all of my Istio CRs in my source control, and I use like CI/CD pipeline to apply it. Why do I need to do this backup? Well, sometimes we've seen that the teams that are responsible for platform update are different than the teams that have deployed this. So there might be like an access problem. Like if after the upgrade, you want to quickly, like if something goes wrong and you want to see what a virtual service used to look like or how things were working before, you want to be able to have all that information directly in front of you. So this is a good way to just grab all that config directly from your cluster. A better way to capture everything from your system, everything related to Istio from your system, is to run the IstioCuddle bug report command. And what that generates is a zip file, a tar file, that when you extract it, looks like that screenshot that I'm showing on the right. It has all the output from an IstioCuddle analyze command. It has all of the Istio CRs that I was talking about, any config maps for like your IstioD config map and the sidecar injector config maps. It has all the logs, the sidecar proxy logs from all of your workloads, as well as gateway logs. And it also has the config, right? Like from every Istio pod, from every workload pod, it has a sidecar configuration. What are its clusters, listeners, routes, etc. This is something that you should probably just periodically grab and save, so that if there's ever a regression and you're not able to quickly identify what the problem is, you can do some quick comparisons, compare the clusters, compare the listeners, compare the logs, whatever, compare the Istio config dumps. So this is a good way to capture the state of all of your Istio config, as well as your Kubernetes config, because it also grabs your pod YAMLs, as well as any Kubernetes resources that you applied. And then dashboards. This is something that we definitely work with our users on setting up, is take advantage of the metrics that Istio is providing you. Istio comes with several Grafana dashboards straight out of the box to monitor the Istio's performance, the control plane, as well as the sidecar, etc. So set all this up ahead of time so that if there is a problem after the upgrade, you have like quantitative data that you can look at to figure out, is my resource consumption higher than before? Is my application really performing slower than it was in the previous version? Like any data like that, you need to definitely have and store it in a persistent volume. So set up your Prometheus and Grafana dashboards, and make sure that they're saving to a location where you have access to for several days. This is a good blog that I linked to on the bottom from Christian that talks about how he set up these. Screenshots are directly from his blog about how he set up these dashboards and monitored the upgrade while he was doing it. And then read the upgrade notes, right? These are different from the release notes or the change notes that go into more detail. The upgrade notes are very specific to what are the things that you should be looking out for when upgrading from one to another. Some of the gotcha special configurations that you need to look out for. Most of the time, when things go bad after an upgrade, it's usually an Envoy filter. It's not that Envoy filters are not like stable. The API itself is stable, but the things that you can do with an Envoy filter can be incompatible from version to version. So Envoy filters are just, dangerous overall. They should be avoided if you can. There's layering to them that depend on, other things to be there in place ahead of time, or they're just too tied to the underlying Envoy API, which can kind of get you in trouble as you upgrade Istio. So whenever you upgrade Istio, make sure you test all your Envoy filters in a dev cluster. And any customizations you're doing in your Istio operator, like any overlays, like extra features like hold application until proxy starts, things like that, where you're customizing away from the default profile. Take note of those and verify that they're working. You can also compare, like I was showing you on the very first slide. You can generate the YAMLs that get created as part of an install or an upgrade and kind of compare them. So, run it with Istio 111 and then run the same with Istio 112 and see exactly what is changing with Istio itself as far as configuration goes. The last little thing that you can look out for are resource annotations. So these are things that your application developers are annotating their workloads to get additional features. There's no easy way to know what all of those are, but if you were able to look at the YAML for all of your deployments and grep for istio.io, most of the resource annotations have that inside the name of it. So you should be able to quickly see what annotations your application developers are using. And then that should help you set it up for an upgrade. If you want a quick, simple upgrade, like do an in-place upgrade where you feel confident that you've done all the gotchas and you're ready to upgrade, and know that if there is a downtime, you've budgeted some downtime, or not downtime, but know that if there is a downtime, you've budgeted some time to be able to fix things quickly. Then you can do an Istio Cuddle upgrade, which will do a direct in-place upgrade of your Istio system. So you update your control plane first, which is the first command. Then you update any of your ingress gateways or egress gateways or east-west gateways, etc. And then you update your workloads, and then you run the proxy status command to make sure that all of your workloads are now using the new Istio version. And if anything goes wrong, you have all of the config backed up so you can quickly look at it. But here are the steps that at a high level that you should follow after an upgrade when something's not working. Like I said, run the analyze, check the logs of Istio-D, or if it's just one particular pod that's not working, check the pods of ingress gateway and that workload. And then if you're not able to figure it out by then start comparing your proxy configs. So you can either run the proxy config command against a particular workload and get that information and compare it with your bug report from your previous, before the upgrade, or you can just run a bug report again and then start comparing, multiple files. Istio has a great troubleshooting doc pages, and I've linked to both of those. And then I've also linked to a blog that I wrote about reading Envoy configuration. So if you do this proxy config command, the output of it can be something that you're not familiar with. I've tried to simplify that down to say what exactly is a listener, a routes, a cluster, and how can you navigate from one to another using a simple hello world example. Okay, so that's update in place, right? Where you feel confident, all the systems, and you're able to absorb the risk if something goes wrong. But what if you cannot absorb any risk? There has to be, you need the most safest approach to upgrade, and you need to be able to roll back everything that you've done. What is the best way? And that's revisions. So revisions at a high level, you deploy a second control plane that runs in the same cluster, and then you slowly migrate your workloads to that secondary control plane, and then you remove the first one when everything works well. So to walk through it, first step, you install Istio 1.12.1. So I already have 1.11.5 in the system. I installed Istio 1.12.1. It creates a deployment, it creates the sidecar injector, but it does not get used anywhere. So next, you you change the label on your namespaces to point to the revision of your new control plane. And once you change the label, you of course have to restart your deployments, your workloads that are inside that namespace. And now the things in that namespace will talk to the new control plane. If you run the proxy status command, you can see which workloads are pointing at the old control plane and the new control plane. So this gives you the ability to test the new control plane with a subset of your namespaces. If things are working well, then you do all of your namespaces, and then you switch on over to your gateways. You deploy a secondary gateway, a canary version of the gateway or test version of the gateway, wherever you want to call it. And then after you deploy that, you can port forward to that gateway or expose that gateway as another IP address and use that gateway to test your ingress, right? To make sure that your north-south traffic is working well. And the reason why we deploy a canary, a test version of this gateway, is because your primary gateway has additional things that are attached to it. Because it's exposed as like a load balancer IP address, that IP address might be connected to your like your external, load balancer, right? Your DNS, et cetera. So you don't want to mess with that. You want to leave that in place and just test it using a secondary one. And once you've tested and things are working well, then you can just go and update your original ingress in place. So that way you keep that same service. You're just updating in place the ingress gateway pod itself. Now, if you don't have to do that, you can now just send traffic to your new canary version and delete the old one. That's an option as well. And then once you've done that, the new ingress gateway is working well. You just uninstall the old revision, and then you should be all set for the new version. Okay, so that's a simplified version of how revisions work. It works. It's pretty simple when there's only a few namespaces, but you can imagine if you have lots of namespaces, going and updating every single namespace label one at a time could be pretty time consuming. And that's where tags come in. You can say that you have a stable tag and a canary tag, and then the tag is what you would use in the label of those namespaces. And what those tags point to, whether it's 195, 110, 111, 112, you can update that independently using the IstioCuddleX revision tag command. So this allows you to change multiple namespaces at once. Maybe you have a set of namespaces that you want to use for testing, and then a set that are your production stable. Then you can just do your test namespaces and production namespaces. But overall, revisions are a great way for you. This is a recommended way to do, the most secure way to do stable upgrades of Istio. And revisions also allow you to jump two minor versions. So you can go from 1.9 to 1.11 or 1.10 to 1.12. Whereas in place, you can only jump to the next immediate version. Jump up and jump down to the next immediate version. Okay, so those are kind of like two ends of the spectrum, right? There's in-place upgrade, which is very simple, and then there's the revision, which can be pretty tedious, one's namespace at a time or group of namespaces at a time. What are some of the larger customers doing that want to do it very safely, but they have the budget to create additional clusters or just run additional clusters in an HA fashion? Multi-cluster actually simplifies Istio upgrade process tremendously, right? Because what you can do is upgrade one entire cluster at a time. So in this example, I'm going to show how you can upgrade, cluster West 1 while maintaining 100% traffic, even if something were to go wrong, right? So let's say you're upgrading cluster 1, and then after the upgrade, the ingress gateway is bad. Well, that will fail the health check, obviously, for the ingress gateway if it's not coming up. And then your external load balancer should have a health check endpoint for that. And then it will remove that ingress gateway from the load balancing pool. Well, that's pretty straightforward. But what if one of your services is down after the upgrade? Well, traffic is already at the ingress gateway in that cluster. So how can you make sure that now your external users are not seeing it? Well, for that, you want to set up failover, right? You want traffic that's going to that web API service to go to web API in a different cluster. And for that, we recommend that you use global service naming, which is you create a new host name and then back that host name using workloads that are in one or more clusters. So in my example, web API.mesh.internal, I'm going to back that with web API that's in my local cluster as well as web API in the remote cluster. And that would look something like this, right? You create a service entry. The box on the left is a service entry on the left for web API mesh.internal. And on the bottom, I'm going to use the workload selector to select all workloads that have a label web API. So that will select both the local web API service, but I wanted to select the remote one as well. So I'll follow the Istio multi-cluster documentation to set up my federation, and then I'll create a workload entry that points to the ingress gateway of the remote cluster on the 15443, which is the pass-through port. And then so this basically acts as a service on the local cluster, but this service points to the ingress gateway on the remote cluster that does a full pass-through, and that's how the remote cluster endpoint gets picked up. So if you look at the output on the bottom, you can see that I have both the local as well as the remote service as the endpoints for my web UI mesh internal. All right, so now, if web API were to go down, I have this new line, the ingress gateway's local endpoint will fail, and it will just send traffic to the east-west gateway on the remote cluster and send traffic. Same thing if it's east-west, meaning from one service to another. If web API wants to talk a recommendation, it'll instead talk to recommendation.mesh.internal, and then that will route to either the local as well as remote. And you can set up locality load balancing so that traffic stays local unless local is down, and then it'll go to remote. All right, so I think, checking the time, I'm actually right on time. I hope that was helpful. I know it was a very high-level overview of all the various strategies. You can definitely dig more in the Istio documentation now that you know what to look for and what's possible. Again, I work for Solo.io. I just want to say that we're hiring. We have we've been in the application networking namespace for almost 5 years. We have Glue Edge and Glue Mesh. Glue Edge is our enterprise envoy. Glue Mesh is our enterprise Istio. We are leaders in the Istio and Envoy community, and we're growing like crazy in all departments, whether it's our customers, our engineers, our field engineers, sales, et cetera. So we have lots of roles open. We're well funded, and we're looking for good talent, especially anybody that knows Kubernetes and Istio. We want to talk to you. Well, again, thank you. I hope that was helpful. Please feel free to ask any questions or reach out to me on Slack. Thank you.